Hi all, today we are going to discuss about advanced dimensionality reduction. So in this video, we'll cover PCA, TSNE, UMAP and autoencoder as well. So let's get started. We have to install the necessary libraries and um, so we are going to use UMAP learn for advanced reduction technique, and for TensorFlow is great for building neural networks, and we'll use it later for auto encoders. .e is primarily for rendering animations, but it's not directly used here. In general, it's useful in the projects, and datasetter is a powerful tool for visualizing large dataset, and Plotty helps us create beautiful interacting plots. So after importing libraries, we're gonna load our data set. So I've saved my data in NumPy files. So here how you can load them, and here X contains the features where which are probable images in flattened form, and Y contains the labels. So after that, we're gonna do data pre-processing. So I'm reshaping X into a 2D array because most machine learning algorithms expect a 2D input. So essentially, this flattens the images into rows where each row represents a single image, and this is the sample image. Now we split the dataset into training and testing. So I'm using 70% of the data for training and 30 for testing, and also setting a random state ensures reproducibility. So if you run this again, you're gonna get the same split. So before diving into algorithm, I like to visualize the data to get a sense of what we are working with. Let's take a look at one of the images. So it basically hand symbols for 3. And so let's go on with PCA, principal component analysis. So PCA reduces dimensions while preserving as much variance as possible. So here how I applied, and we are projecting our data into 2D space and plotting. Therefore, this is great for visualizing patterns in data. Next, moving on to kernel PCA. So kernel PCA adds flexibility by capturing non-linear patterns. So this, you can see the output of the kernel PCA. And let's talk about TSNE, one of the most popular visualization techniques for high dimensional data. Therefore, it's computationally intensive, but it does a fantastic job. So finally, UMAP is other amazing method that's faster than the SNE and retains local structures better. So moving on to next thing, let's build autoencoder for dimensionality reduction. An autoencoder compresses data into smaller dimension and reconstructs it. So this is the graph of various methodologies. So we can also compare techniques like TSNE, UMAP directly onto a scatter plot to see the differences. So this is 3D visualization for PCA, and this is comparison of different multi-methods as discussed before, the comparison between TSNE versus UMAP. So that's it. So in short, we have initialized the required libraries and we have visualized them, techniques like PCA, TSNE, UMAP, and even encoders. Thank you.